Hello and welcome back. I'm Data Science Tom, and in this video, we quickly refresh the difference between classification and regression, which are supervised learning tasks, and then focus on what really matters: how to evaluate each one properly. So, as a quick reminder, we had classification, which predicts categories. For example, spam versus not spam, cat, dogs, birds. Regression, on the other hand, has continuous values, like we want to predict house prices, temperatures, or revenues for next month, for example, which can be any value in between. So if we have labels with categories, we have the classification tasks, and if we have numbers, we are in the regression on the other hand. So here's where things get interesting. We also had a look at the different stages of supervised learning last time: training, testing, and operation mode. If you don't remember them by heart, just have a look at the previous video to keep in mind what is going on. So today, if we focus on the evaluation, we think of we are in the testing stage. With a look at the evaluation metrics, we see that for classification, what matters are correct class predictions. Also false positives or negative predictions. What those are, we see on the next slide. And the confidence about how confident is the classifier for this prediction. On the other hand, regression, which evaluation metrics we will see in the next video, are more between the difference between the prediction and the truth. Like if I have a stock price about $20 and I predict $100, it's worse than predicting like $30, which is much closer to the truth in the end. The average error about every prediction, or large mistakes, as I mentioned, where we divide along differences between what is the truth and what is the prediction. But now we focus on the classification and the evaluation metrics in there. First of all, what we can imagine is a model which predicts again emails in spam or not spam categories. If we see in the testing stage, we have the ground truth labels and the model predicts something. We can see, okay, we have 4 possibilities what can happen if you have those 2 categories. The 4 possibilities are either we have a true positive prediction, which means the category is spam in the ground truth and the model says it's spam as well. It's the 40 values over here where we see, okay, the model predicted everything correctly. Another possibility is that it was actually spam, but the model said it's not spam. This would be a false negative prediction, saying if the spam is a positive class, we could switch this around without any trouble. But in our case, if the spam is the positive class and the model says it's a negative, then it's a falsely prediction, and we call it false negative as the prediction is negative, which would be the assigned label in the end. Another possibility is like having actual not spam, like a negative class, and the model says, oh, it's spam, which is also false because we didn't match the prediction with the ground truth value. Those are called false positives, as we have actually the negative class and the model would say it's a positive. And the last thing is we have actually spam and the model says it's spam. This is a true negative, which we see in the end, the 45 values, where we would correctly predict the label, which is a negative label in the end. In this case, we only have 2 categories. If we have more categories, you could imagine that the confusion matrix, which is called for the evaluation in the end, has more rows and more columns. Those are matching the amount of categories which are in there. So the evaluation metrics we will have a look at on today are the accuracy, precision, recall, F1 score, and for further videos we also will include the ROC curve. And what they are in detail, we see now on the next slide. The accuracy is just the calculation of what was truly correct predicted, like what is the correct prediction of the spam class and what is the correct prediction of the not spam class. This is summarized and divided by the whole amount of data points we have. The whole amount is 40 plus 10 plus 5 plus 45, which is exactly 100 samples. So we divide the 40 plus 45, which are 85 samples, divided by the whole samples, which is a ratio of 85%. If you see this ratio, you can imagine it's much better to have like in this diagonal higher values, and if the accuracy is close to 100%. It's also the same for the next values because precision, recall, and F1 score are all the same. We have a ratio and we try to get it as high as possible. If we have a look at the precision, it's the true positives, like what is correctly predicted in the positive class, in comparison to all the predictions in the positive class. So it's in the end, the ratio of all what we said is spam, but is correctly spam, of everything the algorithm said it's spam. So in this case, we summarize the 40 plus 5 over here to have a 45, and the 40 will get divided by the 45, and we get a ratio of 88.9%. So it's a bit higher than the accuracy in the end. If we go to the recall, we compare the true positives, like the correctly predicted spam, with the false negatives in the end, which means we compare all correct positive predictions with all positive values which are there in the ground truth. So this is the calculation based on the ground truth, and not like the precision beforehand, where we compare the correct positive predictions with all the positive predictions of the algorithm. So the recall is more based on the ground truth of the values. In this case, we divide the 40 of the correctly predicted spam with the 40 plus 10, which are all the positive values which are actually spam. And 40 divided by 50 is 80%. Last measure is the font score, where we just use the previous scores in the end, multiply them and divide them by the sum of both. We get an harmonic mean between both, and we get an 84.2% F1 score. So we see, depending on the evaluation metric in the end, we get different results. But if we highlight all the results, we get a broader context of what actually is a correct prediction, what is a wrong prediction, and where the wrong predictions exist. And now, please don't forget to subscribe to the channel and like the video for more. So to summarize this, those are the most common evaluation metrics for classification tasks. We also have them in the negative way, like if you want to go to the negative class, to the not spam, then we can have the recall on the negative class, the precision on the negative class, F1 score, etc. So we could also switch around the positive and the negative class. This would make no changes at all. Just keep in mind what is important. It's like the wrong prediction will be avoided, will be done to the negative class. It's a false negative. This is the most important part, as the false predictions name always depend on what the classifier is saying. Thank you for your attention for this video. These were the evaluation metrics for the classification, which is part of the supervised learning. And in the next video, we will go on with this and have a look at evaluation metrics for the regression in the end.